difficulties last week.
Yeah, because I went on and verified. I'm like,
oh, good. I don't know if you saw my post, and I'm like, I'm sure Winsome and Kelly would be happy to verify that, yes, we did indeed meet. So, anyway.
All right.
Let me see if I can.
I completed. I actively participated. All right.
Sorry, it's going to take a minute to pull it up just because SPSS takes forever to open on my computer, and it locks my computer. I can't do anything with it. So you guys can keep going if you want.
All right, Winsome, number 3. All right, do you have it pulled up, Winsome?
Yes, I put that each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
All right, in a pie chart, why are the slices sectors different sizes? Pie charts are more visually appealing. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. That seems to be the one. The size of each slice is random. The size of each slice is determined by the number of categories. No, so it's B.
Yes.
That's what you put, Winsome. Yeah.
Yeah.
Okay, sorry. We're on week 9? Oh, no, we're on week 8. Sorry.
Yeah. I wish we
we're on week 9 already. Wow, great. Oh.
So how are bar charts and Pareto charts related? They are identical. Pareto charts are constructed from tossing a coin several times. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right.
And I think C.
I didn't really do anything with Pareto because it didn't really ask me anything on the. So let me find my notes.
So you guys said 3B. Pareto basically is just the Pareto's lined up in order. It's the same exact thing as the bar charts. They're just lined up. They're numerically valued smallest to largest or largest to smallest instead of just randomly all over the place.
All right, so C.
What number was that one?
That was number 4.
Okay.
All right, number 5. Is P the true proportion or the sample proportion? So we conclude that P hat is normally distributed if NP is greater than or less or equal to 10 and N1 minus P is greater than or less. Okay, so is P the true proportion or the sample proportion?
True proportion?
So
the true proportion, isn't it?
I would say that it's the true. Check really quick.
What letter was that?
That's
5.
5.
5A.
I accidentally opened up the lesson 7 group meeting, and if I go off of it, it gives me a 0. So, so I'm just gonna have to.
Oh, lesson 17.
Yeah, lesson 17. So that's okay.
Can you open up a whole new window and go into 16?
It won't let me. I don't think. I'll try.
The group meeting. Can't you save the group meeting?
I don't know if I can.
Oh, it does say save.
I think you can save it. Yeah, you can save it.
Yeah, it just
save it for later.
So.
Okay. All right. Perfect. Yay! Thank you.
Is that what you do, Winsome? You go in and do it, and then.
Yes. Yeah, because I work. Like I said, I worked on mine before I come.
Yeah.
Here. So.
Why is it not?
All right. So I have that the P hat is the sample proportion. Is that right?
P hat is sample. Yes, that's the sample proportion.
No, for P. So the P hat is the sample proportion. So P is the true proportion. Is that what you put?
Yes.
All right.
Sorry, I'm still not there. I'll be there in a minute.
So number 5 was A. Number 6 is what is N? And that is, I would say, A, the sample size. Is that what you have, Winsome?
Yes.
All right. Number 7, if P equals 1/4, what is the smallest N, or sample size, that satisfies the requirement? So the requirement...
I use...
Sorry, go ahead.
Yeah, I use 40 and get it for both ways.
Is that the smallest? Because if we put 1 minus 1/4 would give us 0.75 in the parentheses, right? And 1/4, 40, 10, equal to or greater to. Yeah, it would have to be 40, wouldn't it?
So
Yeah, that's what I got.
I'm getting there.
Wait, 1? So 40 times, yeah. Yeah, it would have to be 40.
That's 1/4.
Nice, Winsome. Because 10, or N times...
It has to be greater than or equal to 10. Yeah, so it has to be 40.
Has to be 40. That's the smallest. Okay.
Yep.
So 8. Use the following information to answer questions 8 and 9. Suppose N equals 24 and P equals 0.4. What is the mean of the P hat?
It's the same. It's 0.4.
Yeah,
and P are always the same.
Yeah, I just put 0.4.
It's 0.4.
Mm-hmm. $24. Okay.
What is the standard deviation? I gotta just find my stuff.
Sorry, I'm getting my calculator out. 0.4
So
times 0.6.
0.4 times 1 minus 0.4 over 24.
So it's 0.1.
Yep,
Very good.
that's what I got.
For standard deviation number 9, right?
Yeah.
Awesome. Love when we are on the same page.
0.01. Is that what you guys got?
0.1, yes.
0.01 or 0.1?
0.1. Because don't forget to take the square root.
Oh, I forget the square root. That kills me every time.
That is the weirdest thing.
Do we have to put these in? It's not saying that we have to put them in.
3. No, I think it's fine.
All right. Use the following information to answer questions 10 through 13. Brittany's batting average is 0.30. We want to determine the probability she will get more than 35 hits.
So greater than 35 hits. And that's P hat will be greater than 35.
Hat greater than 35.
In her next 100 bats. So N is 100. Okay.
P equals 0.3 and N equals 100.
And I
All
got
right, so what is
0.35.
the P hat? Winsome, you're so good to have already done all this.
Yeah, because I couldn't do them now because I have to take my time and concentrate and, you know, I'm slower, so I have to.
All right, so the P hat is 35 divided by 100, correct?
And I got 0.35.
Yeah.
0.35, and it says round to 2 decimal places. Okay. What is the standard deviation?
Is, oh gosh. Find my formula here.
I know all these little formulas. It's the one we just did.
Yeah. 0.3 times 0.7 equals divided by n is 100.
And I will remember to square root this one.
Okay, you get Winsome 0.046.
Yes. And the z-score, I got 1.091.
Okay.
0.046. That's what I got. 0.046. And then the z-score. Come on, Winsome. You're so fast.
1.091. 1.091. If I was doing it with you guys, I would have been all
Okay,
messed
let me
up.
catch up then. Z
1.08.
hat is 35 minus
1.7, I think. Although I need to try one more thing.
E over my standard deviation, which I already did.
Winsome? Did you get one?
I got 1.091.
Okay, and I had 1.086.
Okay, let's see what I get.
You got that too?
0.046 equals. We already found out the standard deviation, right? 35 minus.
Yeah, 0.046.
0.046. P hat minus P over. Is that the one you're using?
I have p hat minus p over the square root of, p times, so 0.3 times 0.7 divided by 100 equals the square root of 0.421 equals that. Okay, 1 over x times 0.05. Oh, you're right. I have 1.091.
Okay.
It was because I rounded it before, and then that gave me issues. And I think it'll be interesting to see how it comes out on the quiz. Because if you use the rounded number that we used from the question above, the number's a little different. So, all right, now I gotta go find my little probability app here. How you doing, Kelly? All right?
Oh, I don't know why I got lost. 35 minus 0.3 divided by. We're not just dividing it by the standard deviation that we found?
I did, but if you rounded it before, if you put the rounded in number, it's just it ends up being a little bit different.
So you just did it all again?
I just did it all again just to make sure.
All right, 0.31 minus 0.3.
Template 0.1376. Well, it'll be 0.138, right? For probability on number 13.
Okay, yeah, 1.138.
That's what I got too. Yeah.
Mm-hmm.
My legs are falling asleep. Taking my shoes off. Sorry. Okay. Hear me just about fall over. All right. If the true proportion of people, sorry, Kelly, are you ready yet? I'll wait for you.
No, I'm good.
Okay. So number 14, if the true proportion of people who support a political candidate is P equals 0.52 and N equals 2,000 people are surveyed, we want to determine the probability the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What's the standard deviation of P bar? So, or P hat. So we get to do this lovely little equation again. 0.52 times 1
minus
0.52 all divided by 2,000.
and square root of that.
0.52 times 0.48 equals divided by 2,000. Okay, I have to do it one more time. Sorry, because I'm dumb on my calculator.
So 0.0112. No, just 0.011. Is that what you got?
0.011.
Yeah.
Did you get that too, Winsome?
No, I got 0.035. I don't know. Mine could be wrong too.
I did 0.52 times 0.48 divided by 2,000.
And then the square root of that is 0.011.
Equals 0.011. Did it 3 times.
0.011?
Yep, 0.011.
That's what I got.
And then what z-score would you use? So we want to see, so let's do z-score here. And that's 0.50 minus 0.52 divided by answer equals, wow. Okay. I have minus 1.79.
So what are you plugging into your P1 minus P?
I'm doing just the same one we did before, 0.50 or 0.52 times 1 minus 0.52 divided by 2,000. So the same standard deviation we've just figured out for 14.
Yeah.
And putting that in. And I rounded down 4 numbers, so I did 0.01117 and then did the z-score from there. Or that was, yeah. What probability do you compute using the probability applet?
So what was that for 15?
For 15, I had minus 1.79.
Okay.
Oh, sorry, not 79. 709. 1.709.
So you have negative 0.02 divided by 0.01117.
Yes.
Is that what you did?
0.01117. And I got negative 1.7905.
All right.
Actually, yeah.
790.
9. Sorry. So negative 1.791.
One. Yep.
Don't let me fool you.
1.791. What probability do you compute using the normal probability app? We are going to we're getting less than 50%
Yeah.
of votes.
So I'm doing the lower number, or the lower figure.
B,
So
yeah.
I didn't understand this. What are these two Z's? What is that?
I think that's strange too. We haven't seen that before. In the lesson, they didn't talk about that at all.
So I didn't, that's why I didn't understand these, because I didn't know
The only
what they
thing
were.
I can think on this is it's just like Kelly was saying. They're asking for a less than number. So for me, I'm going to put in this less than, saying that basically, I think the big Z is for like the population, is the probability of the population mean, and the small z is this is just me guessing, is the probability of the new population mean. So if when you put in that new 50% value. But again, I could be wrong on that. I don't remember seeing that in the lesson.
Yeah, I don't think so either.
I'm going to take my chances and just leave it.
Yeah.
And then if we get it wrong, it's something we can ask her about, and they can give us some feedback on that one. Okay, what's the probability the survey results will show the candidate is losing even though the true P is 0.52? So we put in our Z-score, minus 1.790. Was it 791, right?
1.791. 1.791. And it's less than.
Yep, it's less than. So
0.0366.
0.0366, yep.
Or 0.037.
Yep. But I have to.
All right.
All right, I'm going to submit.
I'm submitting.
Hey, happy
Well, it looks
day.
like we did something right.
We did it all good. Yahoo! Like it.
You got that, Winsome?
Oh, I was changing something. I didn't submit it yet.
Oh, no worries. We did good. We did good.
Okay.
All right. Because I put something in my calculator wrong, it like threw me off. I hate that. And I thought I was doing it wrong, but then I wasn't, so I'm good.
I'm sorry.
Because I recomputed it and then it was right. So
Yeah.
All right.
So let's do 17. I'll just go ahead and start at part 2. Number 1, confidence interval, blah, blah, blah. So A, find the proportion of those surveyed who have been in an automobile accident the last 5 years. And my number was 0.67992, so 0.678, or no, 680.
Yeah, 0.680.
Which one are we doing? The 17, the quiz?
17, no, not the quiz. The one just down on the preparation assignment. Part 2 is down where it says number 1.
Okay, part 2. Okay.
Right.
So the first one was 0.679?
Yes, or 680 technically.
If you round it up, yeah.
The 3 numbers.
All right, so check requirements. So we just multiply the sample by the 0.680. And that's greater than 10, and also the other one, 1 minus 0.680 is greater. So
yes.
It has been met.
Yeah, very good. So for C, Winston, do you want to share C, what you got for C?
determine the margin of error for 95% confidence interval based on these data. I got 0.0288.
I did too. Very good.
Do you put margin of error with an M? Or is that...
I put an M 95%. Like I put M and then like as a little subscript down at the underneath it. I just put 95% just for my own personal knowledge. And they do use M throughout for margin of error. So just so you know that M.
Yeah, because the two times M is the margin of error, right?
Right.
All right. So D, I have for my 95% confidence intervals, plus or minus, I've got 0.6511 and 0.7087 between those. Or close, because depending on if you did the 0.680 or the 0.6799.
Okay. I used Excel for this one, and so I had 0.651 and 0.709.
Yeah.
So, Winston, did you feel like you got that same thing?
For which one? For D?
For 1D. D is a dog.
Yeah, I got the same things.
Okay.
0.7087 and 0.655.
So, how many of you guys were really upset when they were holding off on that little Excel thing?
It annoyed me that I had to do the Excel thing.
Yeah, but
I'm like, wait, you make me buy SPSS and then I can't use it for everything? I thought I could.
Well, was there another SPSS thing next to it that I just didn't open it up?
No, I couldn't find a way to do it, to do what they wanted you to do using SPSS on this.
Yeah, because he kept referring to the Excel.
Yeah.
In the video. Anyway.
Yeah. So I never saw it on SPSS, a way to use it on SPSS. So.
All right, so E, I have 4,269.
Me too.
Yes.
All right, number 2A, my my null hypothesis was P is equal to 0.60, and my alternative hypothesis was P is greater than 0.60.
Yeah.
Okay.
And for B, the test statistic that I get was 5.173.
Yes, me too.
I got 5.174, but close enough.
Close enough. All right, and then C, I had P value of 1.1518 times 10 to the negative 7. And I sketched my little normal distribution, but it was like teeny, tiny. Nothing. So.
Yes, it was, it's very unusual, close to, yeah, it's just close to 0.
Yep, pretty close to 0, so.
Therefore, we reject.
We reject. And then on the little sentence I wrote, we have sufficient evidence to conclude that the true proportion of students in an accident in the past 5 years is greater than 0.60. So.
Yeah. That is it. Good.
All right.
All right. On to the group.
Yep.
Group meeting. So the symbol for the true population proportion is just the P, correct?
Plain old P, yeah. Number 4, the requirements for constructing a confidence interval what?
Are they satisfied?
Oh, so we need to just figure out if it's been satisfied or not.
Yeah, so we just do 100 times 0.5. Mm-hmm. That's greater than 10.
Yeah, yes. And then, let's see, where's my little note?
Oh, it's something minus.
1 minus 0.1090. So, yeah, that's
100, yeah, minus 1. So that's greater than. So it is met.
Both good.
It seems like it would be really hard for it not to be met. It's less than 40 on that one, I guess. It wouldn't have been met.
I think if you had low numbers,
yeah,
it would probably be harder to have it be met. Like if you had 15 people, it might be a little more difficult to meet it. Right.
So for the hypothesis testing, the requirements are, it seemed like they were the same requirements.
Yeah, I put true.
Yep, I think you're right.
Yeah.
And a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 to 8. And for 6 says, find P hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state.
Okay.
So it's just 45 divided by 60.
And I have 0.75.
Yep.
Yeah, 0.750.
0.750? Yeah, 3 decimal places.
Decimal, yeah. And then your confidence interval on the guilty.
I put B.
All right, let me figure it out.
Yeah, I haven't done mine yet either, so P hat is 0.75. So minus 1.96 times square root times 0.25, and N was total of 60, correct? Okay.
1.96. 5 times 1 minus 1.5. Goodness.
Plus, okay, so I have 0.8596. Okay. I have B, the second number down.
Yes, that's what I got too.
Yay! I love that, Winsome. You make me feel good when you say that. I got that too. Yes! With the confidence interval, I would think it will decrease. But
Yeah, I put decrease.
I think,
All right. I'm a little slower, but I did get B as well.
yay!
If you increase the sample size from 60 to 80, I wrote this down. As the sample size increases, the interval decreases.
Yay! That's what I put too.
Yay.
All right. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest N can be, and both requirements still be met. So, all right.
It would have to be 20 as well, right? 20?
Yes, 20. I got 20.
I think so too.
And number 10, I got 100.
Yeah, that would be 100.
Yep.
Hey, that's pretty easy, huh? That's pretty slick.
Yep.
All right. Oh, we're almost done. Yay. 11. I'm so tired. I've been doing homework solid. Oh.
Oh, you poor thing. That's not
All
fun.
right, here we go. Homework and work. For water quality study, I'm reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level alpha equals 0.05 with the following hypothesis. All right. They collect new data, and this time n equals 80 and x equals 38 indicate good health. The conditions for conducting a hypothesis test are satisfied, true or false.
Okay, hold on. I want to go back really quick to number 10. 1 equals. Because I have a different number. I have 90 on that one. I'm thinking I did it wrong. 1 minus 0.9.
Why is it 90?
Because you still have to do that n times 1 minus p is greater than.
And that has to also be met. Okay.
And it makes me think we might want to do the other one on the top.
But see, 10 into 90 only is 9, and that wouldn't work for the other one.
Yeah, it has to be 10 or more.
You're right. You're right. So it has to be 100. Okay. You're right. You got it. Sorry.
Okay. No, that's fine.
I just was rechecking it. So, sorry. And I haven't gone that far on 11 yet. So let's go on to 11. Sorry. Anyway.
They collect new data. So,
your doggy has to make an appearance every time. So cute.
I know, because my daughter comes home from school right now. She's like, all right, it's time to bark.
Time to bark. Okay, 60% of the researchers suggest that water quality in the area is decreased. They conduct a hypothesis test using this level of significance. New data this time. So the conditions for conducting a hypothesis test, I'm going to make sure. So.
All right, so we are putting in.
So it's 38 divided by 80 is our p hat.
Yeah. You got to be nice, guy. Almost done. Okay, so Z, we're finding. Oh, if they're satisfied.
Yeah,
right
and
now.
it's greater than 10. It's true.
Yeah.
And p hat is 38 divided by 80, which is 0. Go ahead, Winsome. What did you get?
0.475.
That's what I got too.
Yeah. All right, Z. Are you just putting this in your tool? Can we put this in the tool?
We might be able to.
Yeah. So X is 38 and N is 60. I'm telling you, I'm using this tool more because I'm sick of.
It's a lot. I know it's a lot to calculate.
Oh, sorry. The new one is 80 though. So okay, sorry. N equals 80. I don't know why I put 60. All right, so did you get the negative 2.282?
I got negative 4.392.
4.392.
Yeah, let me try mine really quick. I haven't gotten that far yet, ladies. 0.6.
Are you doing it by hand?
I am.
You're so good. Okay, you do it by hand, and I'm going to see if it's the same as this.
Okay.
This thing.
That is fine. Okay.
X equals 38 and N equals 80. with a confidence level of,
.6.
what was it, 95?
I have minus 4.017.
So can't you do it in the Excel?
I'm sure you can. I just did it by hand just to see.
Well, my z-score in the Excel with my null hypothesis of greater than 60, right? Oh, wait.
Yes.
So that would be less than, because it
Less
says
than, sorry, less than 60. Let me just see if it comes out the same. Less than 60, 38 and 80, 95% confidence level. Do we know that?
No, they didn't give us that.
So maybe we can't do it without the confidence level? Yeah, the z-score is negative 2.282, so I can't do it that way.
But that's two-tailed.
Well, that's a less than. I have less than.
Maybe not. Maybe that doesn't make any difference. It's
but
not
isn't the confidence level 0.05? How much is that?
Yeah, my confidence interval is 0 or 0.056. Is that what you got? You know what? I'm going to have to do it by hand. I don't know. It's like totally off of yours, Lori.
I'm doing it by hand just because, I don't know. It just, yeah.
The guy said that we can just put it in, and I'm not very happy about that. All right. Maybe I put it in wrong.
See, and I don't know if I just did it wrong either.
Here, I'm going to do it. 4.475 minus.
Oh, I did do it wrong. I did it wrong. Don't count on me because I just realized.
P is 0.6 divided by 0.6 times 1 minus 0.6 divided by n. All right, I'll get it here in 1 sec. I should have not gone the lazy route.
0.4 times 0.6 equals divided by 80 equals square root of the answer equals k 1 over x times 0.475 minus 0.475 minus 0.6. Okay, I have a different number.
All right, I'm almost there.
And it's close to what the probability app said.
Oh, nice! It is. I think mine's exact. Let me see.
Mine's minus 2.282.
That is it.
Yahoo! Okay.
So we don't have to do it by hand. There, good. I'm glad to know that.
Minus
so that means everything else is the same. So.
And the p-value is 0.011.
2.282. The p-value 0.011. And the decision for the test is to reject. Water quality in the area has decreased. Yes, quality.
Yes, they're sufficient.
Has decreased. A, right?
Yep.
Okay. My brain.
No, I totally understand.
You guys made me do it.
Right before we met. So.
Do that.
What was that?
You made me do it by hand, but that's good. Now I
I'm
know.
sorry, it's good practice.
Oh.
Hey,
All right.
I'm submitting.
All right, we got 100. Yay.
Woo! Hallelujah. I need that. Okay. Yay.
All right, so now hopefully we can do the homework.
Yes.
Get it right.
All good. Well, I'm going to try and do that right up, and I will be there. So let's plan on 2 o'clock next week.
Okay, so I'm going to just get home as fast as I can. It might be like a little bit after 2, like 2:03.
So, and I'll probably have to leave by 3:15, so just FYI.
All right, so we will, I'm trying to think if I could maybe even leave work. I don't know. Okay.
Well, if you can, let us know, just, text me or whatever. I'm pretty good about text. Calling me doesn't always work. It just depends what I'm in the middle of at the time, but
yeah, I'll send a text. If I can get off early, I'll send a text, but it would only be like 1:45. I could be here probably.
Perfect.
Okay?
Sounds good.
So, thank you. That was wonderful, ladies. And have
Thank you. Bye.
a good week.
Take care. We'll see y'all.
All right, bye.